In this video, we are going to solve problem based on term symbol. The question is very simple. The ground state of aluminum atom. So what is the term symbol for the ground state of aluminum atom? For that, first you should know the electronic configuration of outermost orbiton. Boron and aluminum, they belong to the same group. So the outermost electronic configuration will be like this. When you go for term symbol, you have to consider only the last orbiton, not outermost shell. You have to consider only the last orbiton. It may be Ns and Np. When you go for valence shell, electron pair repulsion theory and hybridization, you consider both. But when you go for term symbol, you have to consider only the last orbiton. Here you have to give L value. So that is +1, 0, -1. Now only this is filled. The L value is equal to 1. When L value is equal to 1, the term whatever we get is P. That is, for L value 0, we get S term. L equal to 1, we get P. L is equal to 2, we get D. L is equal to 3, we get F. L is equal to 4, we get G. It goes like that. But generally, these 4 are important. In this case, since L is equal to 1, we get P term. So I can eliminate these two options in which they have mentioned D term. So this is not possible. Next, I go for spin multiplicity. It is calculated based on this 2s plus 1 formula. This is capital S, this is small s. This S is nothing but spin, the number of unpaired electron multiplied by half. In our case, we have only one unpaired electron, so it should be 1. And half, what we get is half. I substitute this half in the formula, and what I get is 2. If you see in option A and B, they have mentioned the spin multiplicity is 2. So we need not bother much about this. But still, you should know how to calculate that. Now, we have to go for J value. So this is called J value. In general, we write like this. L, S and J. S, that is nothing but spin multiplicity. L, already we have calculated. So now, what is J? J is nothing but L plus S to L minus S. When it is less than half filled, we go for L minus S. If it is more than half filled, we go for L plus S. L value we know that is 1. S value we know it is half. So L minus S, so it is small s, don't think that is spin multiplicity. If you subtract this, 1 minus half will be half. So this will be the ground state term. That is, doublet P, the J value will be half. Suppose, if the outermost electronic configuration is like this, maybe for halogen you may get this. In such case, L value will be only 1, S value it will be 2, but it is more than half filled. In that case, you have to go for L plus S. That is 1 plus of this will be 3 by 2. In this case, you will get this value. Even though the L and S are same, the J value will be different for this electronic configuration. Based on the term symbol, I have one more problem. For a valence electron in a D2 state, the possible J values are. Here they are given the L value and S, that is spin multiplicity. What will be the J value? So it is, if L value is E, that means this L value will be 2. What about S? The spin multiplicity is 2. That is possible only when S is equal to half. When there is only one unpaired electron, we get doublet. There are 2, then you will get triplet. So basically it will be n plus 1. N is the number of unpaired electron. So now I know S value as well as L value. The possible J values will be L plus S to L minus S. In between -1, -1, you have to go like that. I explained here. So L value 2 plus half, it is 5 by 2. L minus S, 2 minus half, that will be 3 by 2. In between, if there is any number, that also you have to include. But there is no number. 5 by 2, 3 by 2. 2 are possible. Suppose if it is 7 by 2, 7 by 2, comma 5 by 2, comma 3 by 2. So 3 values are possible. But in this case, 5 by 2 minus 1, that will be 3 by 2. So we get only 2 possible values for J. That is given here.